All right, I'm going to go and get started. Um, this workshop is mainly for beginners, so if you have prior experience in programming, um, this might be kind of repetitive and unnecessary for you, but I encourage you to stick around to see, but you're welcome to leave if you find it unnecessary or unhelpful. I'm going to assume most of you are either freshmen or non-CS majors. Just because if you are CS majors, you'd have taken data structures by now, probably, and you would know C++. So I'm going to go ahead and get started then. So just a little bit about me. My name is Sen Francis. I'm from Chicago, Illinois. I'm a sophomore CS major, and I've been programming in C++ for about a year. But I've been programming in general for about 3 or 4 years. So a little bit about C++. That's kind of irrelevant, but I guess interesting. It was designed in 1985 in the AT&T Bell Labs by, I'm not going to try to pronounce that name, but yeah. C++ is a statically typed language, which means types are checked at compile time versus runtime. So an example of a language that checks types at runtime is Python. So that's interesting and affects performance definitely a lot. C++ is an extension of C, which I'm sure a lot of you know or can pretty much intuitively guess. And the main differences between C and C++ are that C++ has stronger type checking, support for data abstraction, and object-oriented programming and generic programming. So basically, it's just a big improvement on what C was. So I guess you could look at this graphic and view it as kind of motivation as why you would want to learn C++. As you could see, this kind of shows the performance in terms of time a program takes to run and memory it takes up. And as you could see, C++ is very much so near the top of the list. And that's compared to a language like Python, which is relatively slow and hogs up a lot of memory. And this is a big advantage in tech. So knowing this will benefit you greatly. And what's interesting about C++ is, unlike C, it's a lot more readable and understandable. So even though it's still, it's kind of like in between a higher level and a lower level language. So you kind of get the simplicity of understanding the code, but it still performs really well. So yeah. So let's talk about C++ files. C++ has two main types of files. One type of file is a header file. The other is a source file. Header files typically include class definitions and function declarations. This may sound pretty confusing to you because we haven't really gone over this, but I will go over classes and functions in more depth later. But basically, no code is really implemented in the header file. It's very much so like a skeletal layout of the code to come. So you're just kind of outlining the code per se in the header file. However, one-line definitions are okay. So if a function only takes one line to complete, you're allowed to put it in the header file. And source files, these are where actually the code all goes. So you use that header file for the layout, and then you put it all in the source file, and you actually implement your code in a source file, which is a .cpp file. So a common question would be, why can't I include my implementation in the H file? And this is because of how the C++ compiler behaves. So if you were to do this, it may actually result in worse performance, or in the worst case, it might actually even fail to compile. So this is an example of a data structures framework from last year, and on the left is an example of a .h file, and on the right is a .cpp file. So you could see what I mean when I said the .h file is just a skeletal layout. So you could see, for example, for the constructor, nothing is actually implemented. It's just kind of like the header, for the function, and that's it. And you could see on the right side in the .cpp file, the function is actually implemented here. And so this is where all the code goes in the .cpp file. And then again, like I mentioned, one-liner function declarations are allowed in definitions are allowed in the .h file, and that's where all these functions come in. So that's allowed totally. And then another example of a function that's declared but not implemented in the .h file is this intersect function. And so you can see no code is actually written, but in here you can see enclosed in the curly brackets, all this code is actually implemented in this intersect function. All right, so now we're going to go over some basic C++ program structure. This is kind of just stuff for every C++ program to function correctly. So every program must have a main function. This is kind of like the driver function for the code, and the code won't compile without one. So you need to remember to include a main function always. Header functions are included at the top of the file. So this is like when you see hashtag include, for example, hashtag include IOStream. IOStream is including the STL library for input and output. So if you wanted to include input and output in your program, you would have to include this line at the top. So it's basically telling the program that, hey, I want to use the IOStream. So you have to include that library at the top of your code. Comments are indicated by 2 backslashes, or a comment block is indicated by a backslash and an asterisk, and ended with an asterisk and a backslash. And if you don't know what comments are just for the programmer to help them understand what the code really is. It doesn't actually do anything. Like you could write anything in a comment and it won't actually affect the code. Lines end with semicolons, always. So yeah, that's just to make it easier on the compiler. Functions are enclosed in curly brackets. So this is an example of a main function. It doesn't have anything in it, but I just wanted to demonstrate what the curly brackets look like. So here's your function declaration, and then here's the curly bracket, which is opening, and anywhere enclosed in the curly brackets, those are statements included in the function. And then here's a little graphic of a C++ program. Again, I haven't really talked about what classes are, but I'll get back to that later. Now let's talk about compilation and execution of C++ programs. Basically, regardless of your operating system, these steps are pretty much universal. And that's obviously assuming that MinGW is installed, and MinGW is just the C++ compiler. So basically what you're going to do in your command line is you're going to navigate to where the directory is stored. And obviously this is going to be different if you're using Ubuntu, Mac OS, or Windows, PowerShell. So you're going to navigate to the directory, and then to compile, you're going to write this statement, G++-O, and then any name. Out can really be anything, but in this case, let's use out, and then the name of the file with the file extension. So that's to compile it, and then to actually execute the code, you're going to do /out. And as I stated previously, out can really be replaced with anything. It's just the name of the executable file. But when you replace out, you're going to obviously replace it here when you're running the executable file too. So if you're not comfortable with using a command line, you can use an IDE. Some examples of IDE that I've used in the past and I can vouch for are Visual Studio and Eclipse. Those are particularly good. This is a nice little graphic that describes how the C++ compiler works. So you start with your CPP file, and it goes to the compiler, and then the assembler, and then the linker, and then you're finally at your executable file that'll run your code. Okay, now let's kind of get into the meat and bones, meat and potatoes of C++. So let's talk about variables. If you've programmed before, you probably know what a variable is, but basically a variable is composed of a data type and an identifier. Some examples of data types include a char, which is a character, a signed or unsigned int, which is an integer, Signed means it includes positive and negative numbers. Unsigned means it's only positive numbers. A floating point number, or a float, that's just a decimal number. A double, which is again just a decimal number. A Boolean variable, or bool, which is a variable that is equal to true or false. Void, which is just null. It has no return type. And then string, which is a sequence of characters. For example, like any word as a string. And then now we're going to talk about identifiers. Identifiers are sequences of letters, digits, or underscores. This is basically what you're going to name the variable. And then in this paragraph here, these are basically identifiers that you can't use. C++ doesn't allow you to use them just because it'll confuse the compiler if you do. So just be aware that you can't technically name it anything, but most things are fine. And then this little graphic is here to help you understand when you would actually use variables. So you could see here you declare the data type, so int, and then you name it something. So we're going to call the variable age, and then you set the value to 20. So now you have a variable age, which is an integer, and it has a value of 20. Pretty self-explanatory, but obviously it's very important. Okay, input and output. For C++, the standard input stream is stdcin. And so basically if you ever want user input, you're gonna use this stream. So for example, if you wanted to assign some user input to a variable I, any variable I, you would do stdcn, and then these two less than symbols, and then I. And this would ask the user for input, and then once the user inputs it, the value will be assigned to I. That's fine, you can attend your office hours. This is recorded as well if you need it. So stdcout is the standard output stream for C++. So if you ever want to print something to the console, this is what you're going to use. You're going to use the output stream. So let's say I wanted to print hi to the console. I would do stdcout, and then once again, these two operators, the less than symbols, and then hi in quotation marks. And then the third stream you're probably going to use is the standard error stream. And so let's say you wanted to print some error that you had, you would use stdcerr. So let's say you had a function and you checked it if you could open the file, and it turns out you can't. You'd want to print to the error stream, and just so it's easier to identify, so you'd print stdcerr, those two operators again, and then error could not open file. And then here, this is just a demonstration or an illustration of all the input streams and output streams. And you can see there's one called clog. You probably won't ever need to use that, but it's still there. These are the main three you will use. Now let's talk about operators. Operators are, again, something that's pretty self-explanatory, but pretty important to learn if you don't understand it. So the assignment operator, which is the equals. So let's say I wanted to assign the value of 2 to x. You would do x equals 2. Pretty self-explanatory. I'm sure many people think this is stupid, but regardless, we have to go through this. And then x is equal to y. So that assigns the value of y to x. And then same thing with the arithmetic operators. It's pretty self-explanatory and intuitive. So you got the plus operator, the minus operator, the multiplication operator, the division operator, and then modulo. This is actually something that you probably won't be familiar with if you haven't programmed before. So in this example, this assigns the value 2 plus the value of y to x. This assigns the value of x minus 3 to x. So you're subtracting 3 from x. This applies the value of 5 times y to x, and then this just sets the value of y divided by 2 to x. And then this is the new thing that you probably won't know. and this is the modulo. And this basically gives the remainder of what you're dividing by. So for example, let's say you were taking 15 modulo 2. So 15 is an odd number, so obviously it's going to have a remainder when you're dividing by 2. So if you're doing 15 divided by 2, there's a remainder of 1. This is what this would equal, the remainder. I remember it was kind of difficult for me to understand that at first, so if you have any questions about that, please feel free to let me know. But I'm going to move on. Here's some more operators. Here are the compound assignment operators. So these actually don't do anything new aside from the arithmetic operators. It's just to simplify the process a little bit more. So we have plus equals, minus equals, times equals, divided by equals, and then modulo equals. So what x plus equals 5 does, it's the same thing as x is equal to x plus 5. It's just a simpler way of writing it, so it's more, so the programmer can be like more efficient or whatever. So, and then the rest are pretty self-explanatory. They all equal the same thing. So yeah. And then now you have the increment and decrement operators. So if you were to do x plus plus, this is equal to x plus 1. So again, it's nothing really that new. It's just for simplicity, really. And then x minus minus, same thing, but with subtraction. And then here's something that's kind of confusing. It's the ternary operator. So let's say you have a condition. This condition can be true or false. If it's true, then the value of this whole statement will be equal to A. However, if this statement was false, if this condition was false, the value of this whole statement would be equal to B. So let's say you had, let's say A and B were integers. And we had this integer, we'll call it temp, or we'll call it C. We'll call this integer C, and we'll say int C is equal to this condition, question mark, A colon B. So if the condition was true, then C would equal A. However, if the condition was false, then C would equal B. So again, if you have any questions, we can go over that again, but I'm going to move on. So now we have our first exercise. I just want to keep you guys more engaged because I know it can get boring just to hear me talk on and on again. So we're going to actually program. So you guys can watch me do it, or you can follow along as well. I'm sure most of you probably don't have MinGW installed or an IDE installed, or some of you may not. So if that is the case and you still want to follow along with me, you're welcome to look up like online C++ compiler, and you'll find plenty of options, and you can just use one of that. And for these purposes, that is perfectly okay. But obviously, if you want to code some more complex programs, that won't be sufficient. So if you're interested, I would recommend downloading MinGW and an IDE or a text editor. So first thing we're going to do is we're going to write a C++ program that asks the user for two numbers. And then we're going to print the sum of those two numbers. Can anyone either in the chat or through their mic tell me how we could do something like this, or if you have any ideas of how we could do something like this? Nobody? All right, I guess I'll just go on and demonstrate it myself then. So we're going to do hashtag include IOStream because remember when I said you needed to include the header files for the input and output? So we're going to include that stream so we have the both input and output options. And so then we're going to call our main function. we're going to define it there. And so now we have to ask the user for two numbers. So how would we do this? Let's say we have two integers I and int j. And then we want to do std cin. Now this is actually asking the user for the input. And so the first number, we want to assign it to I. And then the second number, we want to assign it to j. And then we're actually going to print the sum of those two numbers. So we're going to do std cout, and then obviously the sum of I and j, which will be defined later by this, is just going to be I plus j. And then because the main function has a return type of int, we're going to do return 0. Or you could do a return exit underscore success as well. So now I'm going to go and save this. Call it exercise underscore 1.cpp. So now you can see all the syntax is highlighted. And now we're going to go ahead and try to actually compile this code. So we're going to do g++ -o, and let's say test, and then the file name. So we named it exercise underscore 1.cpp. Oops. So now you can see I got a pretty big error. So does anyone know what the error I got is? I'm going to assume no, but basically we have to convert, because the input stream will take only characters, we have to convert these characters to integers. So I believe you're going to use the atoy function. So basically this is going to cast a string to int. Oops. Apologies, I used the wrong operators here. So for input and output, it's actually inverted. And you can see I spelled success wrong. So then you just save it, then run it again. Then you do /test to actually execute the file. And then you could see, instead of actually completing the file, it's waiting with this underscore. So it's waiting for that user input. So let's say 5, and then it's waiting for another number, 5. And so now you can see the program runs and it completes and it outputs 10. Might be kind of small. Let me make that bigger for you guys. For some reason it's getting cut off, but see, so let's do another test. 2, 2. Right here, it outputs 4. So pretty cool. Now we're going to do this other exercise. So this one's a little bit more confusing. So now we're going to write a C++ program that solves a quadratic formula given user input for a, b, and c in the format ax squared plus bx plus c is equal to 0. And we're going to make sure the program checks for valid input. And there's a hint. A in this case cannot equal 0 because you cannot divide by 0. So I'm just going to edit this function. We're going to do a, b, and we're going to have an integer c. So we're going to ask the user, maybe let's output std cout. Enter value for a. We'll do a comma b comma c. And then same thing to get the input. We'll just edit this stdcn. And so this will initialize all the values based on the user input for a, b, and c. One thing we wanted to check though was that if the input was valid. So we're going to do a simple if statement here, which might be kind of confusing for some of you. So we're going to check if a is equal to 0. And if it's equal to 0, then we're just going to stop right here. If it's equal to 0, let's print a statement, std_ser. So now we're printing an error statement to the output stream. Error a cannot equal 0. And then we're just gonna return exit underscore failure. You don't actually have to do this. You could return exit 0, means the same thing. So now we got the input. Now we're gonna actually compute what the quadratic formula does. So we're gonna do it's kind of hidden on my screen, but we're gonna do negative b plus or minus. So let's just start with that. Do negative b So now we've run into a problem. How are we supposed to compute that square root? Does anyone have any ideas? No? We're going to actually have to include a different library for the square root. We're going to have to include CMath. So this is the math library, and it includes stuff like squaring and stuff like square rooting too as well. So we're going to do squirt. So we're taking the square root of b squared. B squared is the same thing as b times b. And then b times b minus 4 times a times c. And then this is all divided by 2a. So 2 times a. And one thing to note, you can't do this, 2a. Even though that makes sense in your head and it makes sense in algebra, you have to explicitly state for the compiler 2 times a, because otherwise it won't know. So this will print one of the roots, and then obviously we have to do the minus portion for the other root. And so I'm just going to copy and paste this, and then let's do the minus. And so now we should be able to print the roots. Let me just format it a little bit more nicely. So we're going to have root 1 and we'll do that. And then we'll have root 2, and we're going to have that. And so this will print the roots nicely. And just a hint, if you wanted to make a new line, you're going to do this, \n. Or if I wanted to tab, I would do \t in my text. Now let's try running this. Might get an error, but we'll see. All right, so this is a simple error. I just forgot to include one R in the std ser. So we're going to go ahead and save that again and then run it. So we're going to do /test again to run the thing. Let's do 5 for the value of A, 2 for the value of B, and then 4 for the value of C. We see we get this, not a number, not a number. So what that tells us is that we did something wrong here in our math. So let's go ahead and try to find what we did wrong. Let's just try printing the determinant first. Maybe it's dividing wrong. So that's the first thing I'm going to test. 1, 4, say 0. This is a pretty easy test. So now we're seeing that we're getting actual roots. So now we could go ahead and try to put the 2a back and 2a. So 1, 4, and then 0. And so here we see we actually got the correct roots, 0 and -4. So it was probably just a small syntax error, and I just fixed it there. Let me go and plug my laptop in because it's running out of charge. Does anyone have any questions so far on anything that we've been over? Nobody? All right, I guess we can move on then. So now we're going to talk more about operators, but these are different kind of operators. So these are relational operators. So you could see the double equals, the exclamation equals, the greater than, the less than, the greater than equal to, or the less than equal to. The one you're probably unfamiliar with is this, these two. So the equals, this just checks for equality. So in this case, x is equal to 5. This checks if x, the value of x is equal to 5. It doesn't assign the value of 5 to x. It just checks if they're equal. So it checks if they're equal, and it returns true if they're equal and false if they're not. So x exclamation point equals 5 actually does the opposite. This does not equals. So this checks if x does not equal 5. If x does not equal 5, then it returns true. This checks if x is greater than 5, obviously. If that's true, then it obviously returns true. And then same thing for all of these, because these you're probably familiar with from normal math. Then here's a different kind of operator, logical operators. So then once again, we see this exclamation point, we see a double ampersand, and then we see these two vertical bars. The exclamation point stands for not. The double ampersand stands for and these two straight bars, they stand for or. So if we wanted to do exclamation point bool, it would return true if bool was false, because it takes the opposite. So if this Boolean variable was false, it would return true because it takes the opposite. That's what the not operator does. It takes the opposite. However, if this Boolean variable were already true, it would be false. And you could see that kind of in this chart too. This statement returns true if both of these statements are true. That's what the and does. So this statement has to be true and this statement has to be true for the whole statement to execute to true. So x has to equal 5 and y has to equal 2. If they don't both equal 2, it'll be false. And then the or operator, only one of them has to be true. So x has to equal 5 or y has to equal 2 for the whole statement to be evaluated to true. Now in this statement, or in this graphic, this is a truth table for, it basically just, it's a truth table for all the logical operators. So I kind of went over what all these are, but if you're maybe a more mathy person, this may be a good visual for you. In these cases, 0 is equal to false and 1 is equal to true. It's basically the same thing, 0 and 1, true and false. So in this case, if a is equal to 0, or if a is equal to false and b is equal to false, the and operation on both of them, that would obviously equal false. Same with the or operation. However, if you're taking the not of a, it would be true, because exclamation point false is equal to true, because it takes the opposite. Now back to here, if a was false but b was true, a and b would obviously be false because both of them are not true. A or b would actually be true because one of them is true, b is true. And then again, not a is obviously true because it's the opposite. Now let's do the other way around. A is true, b is not. Again, the and operation will return false because both of them aren't true. The or operation will return true because one of them is true. And then the not operation will return the opposite once again. So in this case, it's false because it originally was true. Now we'll have the situation where a and b are both true. So in this situation, finally, the double ampersand will return true because both a and both b are true. And the or, it'll still return true because at least one of them is true. And then the not operation, once again, returns false because it was originally true. Sorry if that was kind of repetitive or annoying, but it's a pretty important thing, so kind of drill that into your head. Now we're going to talk about control structures. Some examples of control structures are if and else statements, while loops, and for loops. So an if and else statement, I actually used an if statement before in the previous quadratic formula code. So this was checking if, so we use those conditional operators to check if a is equal to 0. And if that was the case, then we would return this error output. So that's basically what the if statement does. So if a condition is true, then it executes the statement. However, we haven't talked about this else statement. So let's look at this example. Let's say we have this condition, number is greater than 0. If that condition is true, which it is, we can see it is true. So 5 is greater than 0, that's true. Then this code in the middle will execute. one time. So all these statements that would be enclosed in these curly brackets would execute. Everything in this else code would not execute. It would just skip. So it would go if, so 5 is greater than 0, so it executes all this, and then it goes down here under the else statement. You don't need an else statement, and if you don't have an else statement, it'll just keep moving on. But there are situations where you'd want an else statement. Now let's look at the other way around. We have a number 5, but we could see we switched the operation. So 5 is less than 0. Or 0 is greater than 5. That's obviously not true. So we wouldn't actually execute the statements enclosed in the if statement. Instead, we would move to the else statement. Because this statement isn't true, so we'd move to the else statement. So you'd execute the code in the else statement, and then you'd move on. Does anyone have any questions on that? Kind of a confusing thing, so I can repeat it if you would like. Anybody? You don't have to be shy to talk. There's only like 2 of you in here. All right, I'm gonna keep moving on then. Now we have a while loop. So a while loop is kind of like an if statement, but it continues to iterate for a certain number of times. Hence why it's called a loop. So while the condition is true, it'll keep looping. So this is a diagram. It's kind of confusing with all the arrows, but we're going to start with this condition. So to even get into the loop, obviously it checks that condition just like the if statement. And then if that condition is true, it keeps going and loops through the statements in the body. And then here is where you would update that condition. And the reason you want to update the condition is so the loop doesn't run forever, because obviously you'd want a loop that runs in a specific amount of times, not like just it shouldn't keep on going. That'll actually cause an error called an infinite loop. So yeah, at this stage you want to update the condition. And so eventually the condition has to be false in order for the loop to exit. And yeah. So at the start of each iteration, it checks the condition. So it's just like a repeating if statement. Now we're going to talk about a for loop. It's a different kind of loop. So a for loop, in the beginning part, you're going to initialize a variable. Then you're going to have a condition for that variable. And then you're going to increment or decrement that variable. And then obviously in the middle, you're going to have the statements that you want to execute in that loop. So for example, I'm going to use int. I'm going to initialize an int here to 0. And so while 0 is less than 5, so 0 is less than 5, that's obviously true at the first iteration. So that's obviously going to be true until I is going to be equal to 5. So it's going to actually iterate through 5 times, because at each iteration, it's actually going to be incrementing. So at each loop, at the end of each loop, it's going to be incrementing by 1 until you get to 5. And then once you get to 5, it doesn't execute, the loop ends, and then you go out. So kind of the same idea as a while loop, except instead of a while loop where you're manually updating the value here, you're going to actually update it here and all in once. And it's a lot simpler to use, but there are situations where you'll want to use a while loop. We're going to do some more exercises now. So let's write a C++ program that will print only even numbers from 1 to 100 using a for loop. I'm going to make a new file here. Let's call it exercise_2.cpp. We're gonna just include the standard input. And output streams. And then we're going to do int main. We're going to have our main function here. So the problem asks us to print only even numbers from 1 to 100 using a for loop. So the notation of a for loop. So we're going to initialize the for loop to 0. So we want to print 100 times or through 100 numbers. So we're going to do I while I is less than 100. And then we're going to do I plus plus. Actually, since we're only printing, there's actually multiple ways to do this. Let me show you one way. We could use the modulo operator. So we could do for, we could start it at 0. So this loop is obviously going to execute 100 times because each time it's incrementing by 1. So it's going to execute 100 times. So we're going to do std cout. We're actually going to use the modulo operator to check if I is a even number, because that's what we wanted. We want to do I if I % 2. So if it's an even number, when you're taking the modulo of 2, if it's an even number, it'll equal 0. If it's an odd number, it'll equal 1. So if that is equal to 0, then we're going to print we're just going to print I. And just so it looks nice, we'll create a new line so it's not all cluttered. So pretty simple. And the reason I did this from 0 to 101 is that because if I left this at 100, I wouldn't be able to print 100 here because the loop will terminate once I is equal to 100, so it won't execute here. However, if I were to do something like this, less than or equal to 100, then it'll execute when it's 100. So there, I'm going to return 1 here, and then we're going to try to execute this code. So to compile it, we're going to do exercise2.cpp, and we're going to do /test to run the executable. So you can see here, it's printing only even numbers, 0, 2, 4, 6, 8, 10, all the way to 100. Now, there's actually another way we could do this without using an if statement. And it's probably better to do it this way because you're running the loop less times. So let's say instead of incrementing I by 1 each time, I think it's better to increment by 2. So this time, every time you're running through the loop, instead of incrementing by 1 time, you're going to increment by 2 times. And so